Hello, and welcome to episode 6 of the Networking Podcast. This is the second episode of our new series, Best Effort. And we're here again today where I get to bring the topic and we get to have a nice little discussion about it. So, of course, I'm Bruce Wallace, part of your co-host duo here, and my fellow co-host, Erwan James, is again ready to roll. And
ready to rock and roll.
I think let's just send it. All right. So the topic for today is control plane versus management plane. So I think there's been a trend in the industry over the last few years where we're starting to drive more and more things using a controller, right?
Right.
And there's the classic approach for that controller where you pair BGP to it and it injects routes based on BGP and it's running BMP and it's monitoring the routes. Maybe it's doing some flow spec. And then maybe it's also, maybe there's some PSEP involved if we're talking segment routing. So there's that trend in the industry. I think there's a second trend that's starting to pick up pace now where rather than using kind of control plane to solve all our problems, we are routing guys, we tend to do that, to drive the network using the management plane instead. And this is, a classic example is gRibbie, right? So this is the gRPC routing information based interface, kind of a derivative of GNMI for those of you who haven't heard of it. And this is, of course, being pushed by Google. So this is not throwing BGP at the problem. This is defining another interface, which is its only job is to program routes. And I guess more importantly, to provide validation that those routes have indeed been programmed. So I will flip over to you.
So first of all, I would say that all of that is control plane and none of it is management plane. And that they're two distinct functions to start off with. And even though you're programming something like your RIB using gRibbie, which is inherently using a gRPC as a transport and other, but that's still control plane because you're interfacing with programming potentially a data plane.
So it's a static route control plane as well, by that logic?
Yeah.
Okay, so the title of this episode is Null and Void, and we should just end it here then.
So we're done. So yeah, that's it. And there goes Best Effort, episode 2.
Thanks for tuning in, guys.
I know you want to talk about, but I did think about this a little bit, and I was thinking that it's all really, that's all control plane to me, and management plane serves a separate purpose. But let's do. I think what you want to talk about. I think the topic is more.
Using routing protocols to drive the data plane versus using some kind of northbound control. Because that's really the topic that I'm interested in.
Sort of, or maybe I was going to characterize it as centralized control plane versus distributed control plane. Because everything you described so far seems to be, that, right? Yep, for sure. So, okay.
I mean, I was very interested in not throwing BGP at our problems. That's really what I wanted to talk about. But
all right.
But
okay, here are my thoughts. So first of all, I think that yes, there is a trend for centralized control plane, and although I don't think it's widely adopted quite yet. I think that maybe your big web scalers are doing this. And again, I guess we should also clarify, because we tend not to do this and we haven't done it in previous episodes, whether we're coming at this from like a data center or campus WAN or other perspective. In the data center, I think that there's been moves to do that, but more so from a management perspective, like centralized management. And then from a control plane perspective, maybe, but I don't think it's widely adopted quite yet. And then on the WAN side, it's a similar thing where you have, I think it's more likely to get adopted sooner than the data center. And then within WAN, there's a whole, I just think the challenge, the need for traffic engineering and using things like, signal tunnels, like using RSVP-T, for instance, maybe are becoming troublesome, and maybe using segment routing comes into play, and that kind of pushes the paradigm towards towards centralized controllers. Whereas in a data center, it's pretty simple. There isn't as much of a need as doing the traffic engineering, and therefore relying on your IGP to do it for you tends to work for the majority of the cases out there. And sure enough, you'll have some use cases where you want more granular traffic engineering, maybe a broader view or granular view of the network, and have a centralized controller make those traffic decisions for you. And maybe if you're like a big tier 1 web scale, maybe that's you're doing that today. But I think for the majority of data center operators out there, you're happy with ECMP with your IGP, right? And you don't need a centralized controller to make those decisions for you. Mm-hmm. Whereas in a WAN, I think you're more likely to want to have a centralized view and be able to do more advanced traffic engineering, which having a centralized controller may be more advantageous.
Okay, so you think it predominantly weighs on the level of control you're looking for, and obviously you see a lot more of that in the WAN, where you're wanting to figure out where you attract traffic and how that traffic is forwarded over your backbone to maybe which data centers it's going to.
Or peering, where you're sending the traffic. I mean, what do you think? What do you think that's going?
No, I mean, I think I agree. There's another angle to this, which I think is to do with like data plane validation. But that's not really linked to the centralized versus distributed, but it might be a reason you might want to, stand up like segment routed tunnels within a data center so that you can, you can still do ECMP. It's not like you're doing CBF or anything within the data center, but you may want to have specific paths that you want to be able to probe and test. And that's definitely not for traffic engineering reasons, but you also don't necessarily need the centralized controller to do that for you, right? You could just do like I guess like something like SRT policy or even just like classic SRT based on ISIS or something like that.
Yeah, you could do all that, absolutely. It just becomes a fancy LDP.
And we're all about being fancy.
I guess a stateless LDP.
Yeah, exactly. Okay, I mean, I think everything you just said, I agree with. So this might make for a boring podcast. But what I do want to talk about is the transition from using routing protocols to control the network versus using non-routing protocols. Right? That's really what I wanted to talk about, because that's more of the trend I'm seeing. Whether or not you're doing that based on a centralized controller that has like kind of a more holistic view of the network and is making decisions based on that holistic view. Because of course the problem is that even though you do have like an IGP or something, and we're all doing SPF and we have ISIS or OSPF, whatever it may be, that view of the network, even with, I guess, TE metrics go a long way, but your ability to kind of crunch and analyze data and then make decisions on it is fairly limited. It's fairly, every node is at the root of its graph, right? So having an off-box view of that where you have, like I said, the more holistic view I think is useful. But I do want to focus on the programming aspect where, we do have SRT policy, and of course that's riding over BGP, and, we're peering BGP to the network, and we have BMP for getting, I guess, TE metrics from the IGP into BGP and then into the controller. And it seems like a little bit of a mess when we have, beautiful telemetry and we have ways to get stuff off box, I think, that are better than the control plane method. So I do want to talk about that a little bit. Like, do you think that's valid?
Yeah, so you would be of the opinion that something like BGP LS to advertise your IGP link state to your controller is not ideal.
Nonsense. It's nonsense.
And instead, nonsense. Okay. I'm not sure I agree that it's nonsense, but
there's a better way.
You would rather, yeah. So you would rather do what then? So BMP for your rib?
That's still BGP. Get rid of it.
Okay, so you want just streaming telemetry of your rib /
absolutely,
yeah / what else?
Look, I think when you
can do that.
Yeah, I think when you get to the point where you're focusing on kind of bit efficiency on the wire and the ability to kind of serialize and deserialize data at high scale and make quick decisions where it's all being driven by programs, right? So I think there are better protocols than that than actual BGP. And that's really what I wanted to talk about. Okay. Because, and yes, telemetry is kind of the fancy buzzword we use, but really it's encoding things in proto, or I guess if you're a Facebook fanboy, then Thrift or some other other way to serialize messages on the wire and deserialize them at the far end efficiently, in a programmatic way. And I think we'll just stick to protos because that's at least that's what I know. I think that is the approach. Like that's why I brought up gRibby, right? That's why I see gRibby being useful. I mean, the goals it's trying to accomplish are kind of more broad and grand than just let's make BGP but faster. But let's think of it as just a way to look. There's specific information we're trying to get out of the network. At the end of the day, we don't need every NLRI that's in the network, right? I only care about certain LRIs, and yes, you can use routing policies and all that good stuff, and rib in and rib out, and et cetera, et cetera. I just don't think BGP is well suited for the scalability that we're looking for that centralized controller.
For both directions? So because there's a direction of retrieving state from the devices and understanding what the topology looks like and the state of that topology, and then there's the other direction, which is what I guess gRibby ultimately aims to solve, which is from the controller programming down to the devices, and to your point, beyond just being a BGP update in which you have no confirmation that it was actually that the device did anything useful with it. gRibby does provide that capability of getting that confirmation that the route was installed. So I guess you want
Utopia.
BGP.
I want Utopia.
Yeah, you want BGP out of both. So you don't want BGP. You don't want BGP SR to program your SR, your SIDS mappings, and then you don't want BGP-LS to learn your link state, your IGP link state. You want to do everything using either telemetry. Okay, so you're a big Google fanboy, basically, is what you're trying to say, and you want gRibby and GNMI.
I'm a big
all the
gRPC.
Things.
I'm a big gRPC fanboy. No, look. The collection of statistics is the harder sell, right? I mean, I shouldn't say statistics. The collection of state is the harder sell, because it already exists in BGP. So in order to forklift that, you need to be solving a problem.
Right.
And I think that's why that side of it hasn't really happened. We instead of trying to just stream out the LSDB of an IGP, instead we kind of funneled it through BGP and brought about BGP-LS, right? If that hadn't have already happened, I think this would be more of a discussion. But it has already happened, and it's already there. So unless you're solving a problem, and I don't think I would necessarily be solving a problem. Like BGP is designed to scale, right? BGP is used in the WAN, it's used at the peering edge where you potentially have like an internet routing table that you're exchanging. It's built to scale. So I can't, I can't stand in Utopia world and say, let's toss all that stuff away and let's start fresh, because starting fresh is good fun. No, I can't do that.
Does gRibby provide streaming? I haven't actually looked at it in enough detail to know whether it has models and capability of streaming rib entries.
I don't believe so. I mean, its main job is a kind of controller southbound interface, right?
Right.
I mean, maybe I should have looked at this before we jumped on, but this was meant to be a shoot the shit episode, and so
you think in that case for you it's basically GNMI or some sort of gRPC based streaming of a rib.
Yeah, and the LSDB, right? Not just the rib, but yeah, the LSDB. I mean, I think there's a few things we're trying to accomplish, right? Like if you look at BMP, the whole idea that you can stream both the rib in and the rib out towards, before you're applying your policy, this is valid for sure. I don't know about the rib in part, and maybe this is because I haven't worked too much in WAN networks. Like the idea that you need to understand the rib in, I don't know. But I do think there are better interfaces for sending bulk data, especially when the other end of that interface is an application, right? It's another bit of code. Right. And it's too late for us to unwind work that's already been done because, like I said, it already works, right? Like BGP-LS is there, and BGP is kind of like ubiquitous with WAN networks these days. So every router you're talking to is going to implement BGP, and so yeah, I can't stand up for, hey, let's toss away BGP and just funnel everything into some kind of gRPC interface. But I think it's worth the discussion on like why we as network engineers just continually throw BGP at every problem we have. I guess you like there's BGPLU, there's flow spec, there's BGPLS now. I mean, it's insane.
Yeah, it's I guess because it's true and tested. It's easy to add extensions to it, seemingly, and yeah, it doesn't solve every problem, but it tends to solve most problems fairly well. Yeah. Not all problems very well, I guess, but or even a small number, but yeah,
that's fair.
But what about skipping the whole like programming a rib thing and going deeper and just having the capability of programming the fibs directly through some?
Don't say OpenFlow to me. I'll slap you.
Say what?
We tried this. We tried this with OpenFlow. I mean, and actually,
exactly. So that's what I was going with. That's what I was going to go down. That's exactly what I was going down the path. Is what about that method? Now,
who's the Google fanboy now?
But assuming. No. But assuming OpenFlow was a more scalable, maybe than it is, right? Mm-hmm. And I'm not like an OpenFlow expert, but let's assume that it was a better protocol than it is today. Would that be a better method than actually relying on your devices understanding rib in, rib out, and understanding that they can make a decision on the rib depending on what they want to put into their fib? Like you just have your controller program that fib directly. And just that's it.
Yeah.
Why suggest anything with a rib when you can just tell it what to do with the rib with the fib directly?
I think the only logic for having the rib there is for fallback reasons in my mind.
Exactly.
Yeah. So like if you even if you look at like a segment routing where you are using a controller, right, where a controller is kind of injecting all the paths for you, you've always got your classic IGP or BGP just sitting underneath the hood exchanging prefixes for a fallback where, okay, I don't care about traffic engineering at this point, just forward, please. Like don't bin traffic. And if my controller's having problems or something's restarting, then at least your network isn't dead. It's still functional. So I think that's the only reason I can really think of. I mean, there's the whole best path selection aspect to it as well, but in this case, you have a single controller, right? You have a single source of truth, so I don't know if that's necessarily valid here. I would say, fallback. We don't like our networks to fall over entirely just because their best path has gone away. That's kind of the beauty of routing, right? You can have a secondary path. You can have a less preferred prefix match that may not forward traffic like on your optimal path, but certainly can get the job done, and you aren't going to bin traffic.
So with gRibby, if I have an open gRPC connection between my controller and my device, and I'm using that connection to send routes to be put into the rib of my device, and then that connection drops, is that an indicator for my device to remove the routes which were previously advertised by the controller?
Yeah, I haven't looked into exact implementation, but that's the general philosophy of these style of interfaces, is that they are kind of ephemeral and their state exists as long as the session is active. So if the session goes down...
The TCP session is really the health check for the controller to
I mean, they may have like
whether...
They may have like a keep alive RPC that they're hitting or something. That's pretty common for these kind of services, just so you can check application liveliness as opposed to just socket liveliness. But yeah, and if that goes down, then the route gets withdrawn, and then what you still have your IGP or some other less preferred.
So so in that case, you're still requiring an IGP to be running between your devices. They're just not going to be. You're just going to override basically the rib with whatever you want from your controller, assuming then the device takes the routes from your controller as preferred routes, or at least depending on what you send it. It potentially could be preferred, or hopefully will be if you're trying to alter traffic patterns.
I mean, I don't think there's a requirement per se for gRibby to do that. Yeah.
Correct. Yeah, in fact, I think it isn't. Yeah, you don't necessarily have to do that, but okay. Interesting.
Yeah. But I'd say that's probably how it's going to commonly be deployed, right? Where you have a controller and he's like, I know better, but if I'm not talking, you should still have a brain and still try to get traffic from point A to point B. At least I think. That's how I would build my network. I mean, at the end of the day, like, we build things without single points of failure, right? Like that's how at least WAN networks have operated for a very, very long time. That's why you see, again, if we just model like the tier 1 networks, they typically don't do top of rack redundancy.
Right.
within the data center. But if you break out into the WAN, those routers probably, not that they're going to be dual homed, but they are going to probably be dual homed. But you might care more about things like control plane redundancy and the ability to do like a routing engine or a CPM switchover or something like that. Whereas you don't see that stuff too much in the data center. But yeah, and I would say the same philosophy applies to where you're getting your routes from, in the sense that, sure, I may select a best path or a better path for you and program that, and it's going to be more preferred. But if I don't tell you, or I stop talking to you, or I die, or I go away, please continue to forward just using your best path based on some like a dynamic routing protocol like BGP or an IGP.
And gRibbie has the capability of installing SIDs, like SID paths to like head-end nodes.
I assume so. Yeah, I mean, I haven't looked specific. I'd be very surprised if it didn't. I mean,
so how does that then compare to like something? I mean, in your opinion, something like PCEP. So if you have your controller, it's not, PCEP is another mechanism for your controller to then, signal, I guess, or program SID paths to your head-end nodes.
What protocol does it use
that is
for
not
that?
BGP. That is not BGP. What's not BGP? Which is the key here, right? It's another protocol. No,
I mean, I think look, a standard way of doing this is great. I'm all for that. Like we need to deal with interop, and I think it's great. I don't know enough about PCEP to be able to speak intelligently about it. Like, does it provide the kind of validation that a path has actually been programmed, for example?
You know what? I should know, but I don't. I don't think it does. Don't think it does, but maybe I'll do a quick check real quick.
All right. Well, while you're doing that, because I think that was one of the main goals of gRibbie, right? It wasn't just, it's that whole safety aspect in networking, that not only do you want to acknowledge that the control plane, I'm going to use your terminology here, has accepted the route. You want some kind of acknowledgement that the data plane has actually programmed the route. So this is going right down to like an SDK call to an ASIC, and that call being returned valid. And then there's also like the validation aspect that you can go even deeper, right? And then go and do an audit of, your LPM or something to validate that the route actually is there as you programmed it. Not that I don't think gRibbie mandates that, but certainly that first part, it does kind of mandate that it's looking for a confirmation from the network that the route got programmed.
Correct.
So yeah, I don't know if PCEP does that. I don't know. I don't know enough about PCEP, like I said, to be able to speak too intelligently about it. But I mean, if there's a standard way to do this and it's not using BGP, then sign me up. I'm interested.
Well, PCEP is an option. I'm just trying to see if it does validation. A quick Google, my Google foo is failing me, and it's not coming back right away. But anyway, I'll look into it. But I just want to toss it out there as another option, since we did talk about gRibbie and what gRibbie brings to the table. I guess the other thing there is that, for any of these, the biggest challenge is always getting adoption within your devices, right? And the WAN device, so like there's a big movement into white boxes in a data center, mainly because it's a fairly simple protocol stack. It's a fairly simple use case. And like I said earlier, less requirement on traffic engineering beyond what's provided by your IGPs. But in the WAN, obviously that's a bit more complicated, and therefore the white box concept has not yet really made its way there. So now if you wanted to implement something like gRibbie, now you need your vendors most likely to implement that interface. And also with gRibbie, I believe they model the rib in a very specific way. And so you need your vendors to implement their rib modeling for gRibbie in a very specific way, which I know is actually not as simple. I think the way, from the folks that I've spoken to about this within the vendor space is that the way the rib is modeled in gRibbie, so it has a name. I'll have to look it up here real quick.
Is it the AFT? So open
AFT
stuff?
models. Correct. Thank you. Yeah. The AFT exactly. Then it's like, it's it's ideal. Like if you were to start from scratch and you needed to model something and you had nothing else to look at, it's fairly well done, and it's ideal. But then to translate onto what vendors actually do in their WAN routers, especially since the WAN devices tend not to be, they tend to be more closed, I guess, or like proprietary silicon.
We already
like,
deal with this. They're
yeah,
open.
exactly.
With last
but the
episode,
point is,
we covered this.
exactly. The point is just that the way the AFT model doesn't necessarily cleanly line up with how vendors today model their ribs, and therefore you need some sort of translation layer. And then what that looks like is maybe a little more complicated than it may seem from the outside. So I think adoption of gRibby is probably even more complex than it would be for like the majority of open config models.
Yeah, you could be right.
Which may be the problem, the crux, the issue with gRibby.
Yeah, I think, I mean, the semantics of it aside, right? Like how it's modeling things and stuff like that. I think this is one of the reasons I am a little bit of a Google fanboy, right? Is the idea that you can take a concept that we think we know and kind of draw it back to its roots and then build up from there. Whereas, we kind of get stuck in the baggage we've had for years and years and years. And, GNMI wouldn't exist if Google didn't think, like, why are we putting everything over SSH and SNMP, right? I mean, even NetConf is over SSH.
Yeah, no, it's amazing.
It's
amazing.
It's madness. So the move to gRPC, of course, that was huge.
Yep.
And now we're starting to see a lot of adoption of GNMI, and I think it's really the issue of kind of the iterative process. Now, iteration is great. Like, I'm not going to throw stones at iteration in general, because it's how you consistently improve on something, right? But sometimes it is worth thinking, is an iteration necessary here? Or is this really like, what are we trying to accomplish? And maybe we should wind things back and rebuild from, there's still a foundation there. It's not like we've reintroduced or recreated routing and IP. Like, we still have the same fundamentals, but I can appreciate the constant reinventing. Even though, we work for vendors and that sucks for us. It's much, much easier to iterate than it is to kind of reinvent. But yeah, I don't know.
I mean, you can see where they're going with it. I mean, you could see the ideal behind something like gRibby. I just think it's hard to implement. I think it's hard to push your vendors to implement. I think if you're Google, you probably have a bit more. It's easier for you to go and ask your. Yeah, I mean, exactly. You can push your Google weight around and get your vendors to hopefully try and implement it, right? But yeah, if you're anybody else, like short of being another tier 1 web scaler, that's a tough ask, I think, unless you got, huge adoption in the industry. You're going to get quite a bit of pushback from your vendors, I suspect, in doing so. But then again, it's like who, but then again, it comes back to who's really doing the centralized controller stuff. I mean, we know the tier 1s are doing it, but the majority of the WANs out there, I suspect, are still running, RSVPT as their signaling for MPLS tunnels, right? Which like it works. Like, we maybe have some challenges at scale. It may have management challenges, but it's not like it's completely broken. It's just segment routing provides a better way of doing it. And then segment routing tends to, even though it's not required, certainly you can run segment routing without any sort of centralized controller. It certainly leads you towards using a centralized controller for traffic engineering. Because
yeah, for sure. I mean, I remember going through the transition when I was back in New Zealand working for a provider back there, where we went from a full RSVP core where every time you stood up a node, you had to go and touch every other node to build LSPs, and then of course your LSRs have a bajillion transit LSPs on them, and you're running into scaling problems there. And then they went through that kind of transition where instead of doing like a full RSVP mesh, you instead just did RSVP to your next hop, and you ended up with this whole LDP over RSVP stuff. And the only reason you had RSVP was purely for fast reroute. Like that was it. That was all you needed it for. Yeah. And then we kind of introduced like TILFA and a bunch of the other, I guess, fast reroute mechanisms outside of RSVP, and then they went away from RSVP entirely. But the ability to signal the traffic engineering part of it was lost, right? And I guess that's what segment routing was really trying to solve, was we still need the ability to traffic engineer a network based on information we're getting from the IGP or elsewhere. And the ability to do this off box in a centralized controller where it has access to all the information and typically access to much more powerful compute resources, right? Because there's a lot of crunching that happens outside of just doing SPF. It all made sense. It's just the mechanism for pushing change into the network and the mechanism for extracting state out of the network. I don't know. I wish we'd questioned before we kind of just went all in on BGP. And like I said, I'm taking a purist approach here because we're speculating and but
I think it's ideal. I think it's ideal, but I think it also brings a whole new challenges in having to have that controller, like the actual control itself. So either you need to buy one from someone, build one, maybe open source projects out there that are doing that type of stuff.
Are there any?
I don't know. I'm not sure. Honestly, I'm not sure. I don't know. But that's another challenge, right? For most operators out there. I think that's not, I know all vendors or most vendors are certainly pushing something that would do that. But if you're trying to do your non-vendor stuff, I think in the win, non-vendor's hard. Unless you have a set of developers that are dedicated to building this centralized controller that can speak whatever you want, receive GNMI streams and program using gRibby, and your devices all supported. I think that's all ideal, but unless you're a tier one, I don't think you have developers sitting around waiting to do this.
I guess that's why OpenFlow was so appealing to some people. I mean, despite scale challenges, right? Is that OpenFlow really gets implemented in the data path. So, I mean, you need an agent of sorts, but really gets implemented in the data path. And as long as the chip supports it, you kind of get this multi-vendor, again, utopia, where you don't need to deal with interop because you're just programming the fib directly. Yep. So, I mean, it's interesting that it didn't take off, that we didn't solve the challenges of OpenFlow. But
I don't know if that's not, I mean, it didn't take off as much as maybe it should have. It had a bit of traction. I didn't, Google's B4 network, they have papers out there where they mention the fact that they're using OpenFlow with a centralized controller to do a lot of it. And of course, they obviously solved the scale issue somehow of OpenFlow. I mean, they've done something to it, I suspect. So, and others, I know there's other solutions out there, vendor-based solutions that are still using OpenFlow. I mean, it's not ideal, but it did serve its purpose, I guess, to some extent.
Yeah. No, I mean, I guess that's true. Maybe the question of why it wasn't more widely adopted, it could be the vendor's fault too, right? Like at the end of the day, most customers consume these solutions via vendors. So if vendors continue to push non-OpenFlow solutions, then the rest of the market ends up with non-OpenFlow solutions. I mean, unless you go the Microsoft route and open source everything. Some things, I should say. Some things.
Yep.
Yeah. Okay. All right. I mean, I don't have too much else to talk about. Because I don't want us to talk about segment routing in too much depth here, because I feel like that's an entire another segment in and of itself.
Ooh, look at you. Segment routing is another segment.
Oh, I didn't even catch that.
Sure
I
is,
didn't
Bruce.
even
Sure
catch
is.
that. Yeah, that was totally intentional, guys. I just go puns. I'm so awesome. Puns just naturally happen.
There you go.
Yeah. No, all right. So the general consensus is that BGP exists because it was easy and it's what was done.
Yep.
And interop is great, and driving these things through the ITF is awesome. And I mean, we could segue into GNMI and why that succeeded or is succeeding. I wouldn't necessarily call it succeeded yet, but because that's not driven through standards bodies necessarily, right? Or it wasn't. I don't know if it has been picked up by the IETF.
Also question how widely used it is. I mean, is it awesome? Yes. Should it be more widely used than it is? Most likely.
Yeah, if you look at most
used?
vendors have an implementation now, right? I think all vendors actually have an implementation of GNMI now. So that's
true.
kind of the telltale that something is getting traction in the industry.
Yeah, just
And,
streaming telemetry as a overall is not hasn't been
Yeah, you're right.
consumed as
Yeah.
much as it should, and I think it's growing though. I think that's growing.
Yeah. And then eventually we can push the LSDB into telemetry and we can get rid of these controllers pairing to the network. Huh? What do you think?
Done, easy peasy.
Yeah, I guess, okay, it's the age-old problem of you need to be solving a problem in order to make change, right?
Exactly.
So if you were there at inception, maybe there was a chance to argue these points, but, you know, years later, it's tough to tell people. Although I guess PSEP is an example of that actually working. Like we didn't really need, like you could have done this through something like an AFT, right? You could do all of what PSEP does through AFT and BMP in theory. So we sometimes do make good decisions as an industry. Take that one away from this episode, guys.
But we could be making better decisions.
We could.
Or at least advancing. But I, like you said, I think just to summarize, like you said, it comes down to solving a problem. And I think for a lot of the operators out there, that need isn't there yet.
Yeah.
This isn't a problem that these things are solving for them. That's nice to have. And I'm going to have my engineering and architecture teams look at it because it looks like that's where the industry is going. But it doesn't right away, make an impact. And therefore we'll get there.
We'll get
when
there.
and if needed. Yeah.
Yeah. I mean, it's again, there's a little bit of a segue into segment routing because I think that's very, very much linked to that. But I don't know, segment routing doesn't have as much of a wide deployment as we would have thought by this point in time, right? And there's also the whole, I don't want to call it the upset, but the whole debate around, SR-MPLS versus SR-V6 and having a native V6 data plane. But I do think that warrants its own episode.
But is that it? Yeah. Okay. Okay. Let's do another episode. That's a good one.
Yeah. Because there's a lot there. SR-V6 is crazy, by the way, guys. Just was crazy. That's my opinion. It's my 2 cents. It's crazy. Madness. Absolute madness.
I just think that's driven by what you have deployed today and how much you want to go ahead and overhaul your network to some extent.
You mean like ripping out BGP and moving to gRPC style interfaces for northbound?
Exactly.
Like that kind of overhaul?
Precisely. But if you think about the amount of work that people have put into going from IPv4 to IPv6, I think it's probably a similar amount of work to go from, to get to gRPC based signaling and gRPC based programming.
Oh, you think? I don't think so. I mean, it's not insignificant, but I mean, the overhaul from V4 to V6 was an overhaul, right? Like most customers still haven't gotten there.
No, true.
And I mean, when was V6 created? I should go look up when that RFC was actually, when it was turned into an RFC.
Because it's embarrassing. It's embarrassing.
I bet it's over it's at least a decade.
It's more than that. Gotta be more than a decade.
Oh yeah, I'm old.
Look it
I'm
up.
old now.
Look it up, dude. Look it up. Look up the very first.
IPv6.
We should know this as network engineers and architects. We should know this, but
yeah, I mean that just goes to show, though, right, that it's not like it should have already been deployed everywhere. I'm looking at it. It says mid 2000s on the wiki page of IPv6 deployment. Mid 2000s. IPv4 been in use since 1982. IPv6, this is a good statistic for those of you at home that are still paying attention. IPv6 availability from Google, at least, is around 30 to 33%. So only a third of Google users have IPv6 reachability. That's actually higher than I thought. To be entirely fair, that's higher than I thought. I thought it was much, much less.
But by the way, I'm seeing here the Internet Protocol version 6 specification, December 1998. What was that?
December 1998?
Yeah.
And only 30% of Google users.
Yeah.
Damn.
Isn't that crazy?
Oh, yeah, I see that. Alpha quality IPv6 support in the Linux kernel was in 1996.
Yeah. So it's like, oh, wow.
I mean, yeah, this is one thing that has taken an absolutely phenomenal amount of time to adopt. I feel like this is another episode. IPv6 adoption, why we suck, why it was hard,
SRv6 versus SRMPLS.
and why neighbor discovery is better than ARP.
We should have like a debate series where we each have to pick a side. We draw out of the hat who gets which side, and then we have to debate why one is better than the other.
Oh, I like it. it.
So we should definitely debate like why we're still on IPv4 versus IPv6 and why there's no need to go to IPv6. And then SRv6 versus SRMPLS. And then we can do neighbor discovery versus ARP. And other people should send us their ideas for this debate series.
Yeah, no, that's a good idea. I like it. I feel like I could debate all of those topics with you, honestly.
It's true. All right, I think we should wrap it up. What do you think?
Yeah, I think so. I don't know if we really solved world hunger on this one. I feel like we did better on open, but
we probably did. But
yeah, but this was a topic that I don't know. Again, it's the ability to stand back and take like a utopia view of the world and then argue that view is it's very easy to do, right? Because it ignores reality. But yeah, I do wonder if over time we're going to find scaling issues with BGP. Like when you really scale this up to like the ninth degree, and you have so many, I guess, LSPs that you're trying to advertise to a controller. Yeah, I don't know. I mean, the networks themselves, because we're constantly improving interface density and speeds and feeds, right? It hasn't actually, I mean, the number of elements has of course gone up, but it hasn't gone up exponentially like you would have thought it might if everything was still using 1 gig attach. And the way we scaled out peering was by peering more and not just peering at higher speeds. So, speeds and feeds have helped curtail the problem, I do think. But if you look at the tier 1 networks, they're colossally large, right? So, and they've certainly gone to this centralized controller approach, and obviously Google is the one pushing things like gRuby. So they clearly seem to see the value. I wonder if that same value will be seen by the rest of the networking world, so to speak.
Yeah, hopefully.
Not yet, apparently. Not yet.
Not yet. To be determined.
Okay, I think we can we can call it there. Let's cue that beautiful outro, play some music for you guys. Thank you so much for listening if you stayed listening this long. And if not, you can't hear this now, so who cares?
Exactly, so who cares? All right. Have a wonderful evening, everyone.
Yeah.
Because it's evening time here, so hopefully you're not listening to this in the morning.
Yeah. And we will catch you in the next one.
Yep. Bye-bye.
Hey everyone, thanks again for tuning in. As always, please do let us know any feedback or criticisms you may have. We can be reached on Twitter, YouTube, or our website, ntwr.kn, where you'll find this episode and many others posted. For those of you on YouTube, if you liked the episode, please hit that thumbs up button. And if you didn't like the episode, feel free to hit the thumbs down button twice. On a side note, you know those cliche, these are our opinions and not that of our employer statements you hear all the time? Yeah, we unfortunately have to make one of those. The benefits of working in the industry we want to publicly have an opinion about. We've done our best to remove bias, but we're only human and we make mistakes just like you. Thanks again. We'll see you in the next one.